So as of now, we know how to define knowledge graphs. We also know about two of the techniques that are, in fact, three of the techniques that are used to create knowledge graphs. The first is domain expert created. The next, if you remember, is from students' data. And then finally, a combination of the two, which is a hybrid. But now at this point, we want to figure out how do you, once you already have a knowledge graph, how do you refine it? Okay. There are a number of approaches that could be used. Among others, the hybrid techniques we've discussed are always there that you could refer to and use. You could also use Bayesian networks where the knowledge graph is represented as a Bayes net. The nodes in the Bayes net are the knowledge components, and the dependencies between the nodes, the conditional dependencies between the nodes, will be the prerequisite relationships amongst them. We can then use student performance data to figure out probabilistically whether the Bayes net we have created, which represents the knowledge graph, really does a good job at predicting student performance. Maybe we might have to modify it gradually, in some cases split nodes into two, or sometimes merge nodes. A number of experiments have been conducted to test the goodness of fit and the usability of Bayes nets to refine knowledge graphs, and it works. Okay. In other cases, and this work I'm going to present is not published yet. I've been working on randomized experimentation where you take an existing knowledge graph and then you figure out whether you can change the order in which the knowledge graph suggests students to learn the components, and then figure out using a pre and post test whether the students actually did better choosing one route or the other. So again, just remember, you just randomize the instruction and then do a pre and post test. And by the way, you're randomizing the instruction delivery order based on suggested portions of the skill graph. And then you find out pre and post whether the students are doing a good job at it or not. The results are promising. We have not published it yet, but it is out there. And once we get the data, we'll make that available for or publish that work. But I guess the question is, why is all of this relevant? You may remember from some of the initial slides we talked about, and I think in this second or so video, we discussed that and mentioned that a lot of the intelligent tutoring systems we have around actually use knowledge graphs to inform adaptation. So it determines what items they want to give to students who are struggling, or sometimes students who in an assessment that's adaptive in nature. Knowledge graphs can be used to make predictions or to make suggestions, recommendations of which items to give. Sometimes to for remediation purposes, you may give a student a set of items, a set of skills to assess them on. You notice they are not doing so well. You can traverse the knowledge graph or the skill graph to figure out whether any of those is contributing to their poor success or poor performance in the current work. Many systems use it. Alex uses that. Assessments also uses some of these skill graphs. If you remember, I showed you an example of that 2 or 3 presentations ago, where in fact, it was in the introduction to knowledge graphs video where you notice I showed you a screenshot or a small snapshot of some of these knowledge graphs from these two systems. It has been very effective, and more systems are being built and even extended to other domains like Python programming and the others to ensure that students get the most out of this material. There's a lot more about knowledge graphs, which we're not covering right now in these videos. There's a set of videos for learning factors analysis, And then there's also how learning curves are used to infer prerequisite relationships or knowledge structures from students' performance data. My recommendation is to check the resources that I've provided in the module. Watch some of the videos. They are very good videos. They were prepared by Dr. Ryan Baker. He did a very good job of explaining them. You can then infer from those videos additional resources, additional tools that you could use to learn more about knowledge structures. I hope you've enjoyed this series of videos, and I look forward to, again, answering any questions you may have about the techniques that have been presented in this video. Thank you very much, and I hope to talk to you soon.